just another thing I wanted to ask you about with regards to quantum mechanics is completely random. But that thing I read about whereby you've got a particle in one place, quantum entanglement, and you turn that particle and there's another particle somewhere else that turns. What the fuck is that all about? Like, seriously. And how do you know those two entangled? And can other ones be, could there be two entangled from different ends of the universe?
Yeah, well, I guess the good way to describe it is, when all the way back to when I was talking about these photons or whatever being able to exist in two places at once.
Yeah.
So say your photon hits a mirror and half gets reflected and then half doesn't. So, it's in this quantum state. So half of that could go off to one side of the universe and half could go off to the other side of the universe. They're linked. So if you do something to one of those, if you measure one of them, it either appears on one side of the universe or it appears on the other side of the universe. So this quantum effect, if you like, is very long distance.
And it's not just photons, it can be electrons too.
Yep, yeah. So actually the best way to describe it is it's anything that's like super isolated. So you basically want an object that's not in contact with anything. So it can't be bouncing off. If it's a single atom, so there are ways of making qubits out of single atoms. Those single atoms cannot interact. They can't collide with another single atom because that basically acts as a measurement, like we described earlier. It destroys the quantum stuff. Any quantum effect, any quantum mechanical effect will be destroyed if it comes in contact with a non-quantum thing. So if it's a single atom and it collides with another atom, then it's destroyed. If it's an electron, it has to be super cooled because if it interacts with another atom or an electron, it'll be destroyed. If it's a photon, so photons are good because they don't interact very much, but if it interacts in a strange way with something else, the quantum effect will be destroyed. Right. So this is why all of these sort of platforms are they're all weird. They're either super cooled or they're in very high levels of vacuum. So you're sometimes talking about single electrons or ions in very high levels of vacuum. All of this is just designed to have very, very isolated systems.
I know. It might be quantum entanglement that Einstein talked about and said it's super weird. It doesn't make any sense. In your beer sessions, and you're kind of discussing this, is anyone trying to understand, even though you say they can't, are people trying to figure out why this is happening? Of course they are.
Yeah.
And have they made any progress?
There are a bunch of, am I allowed to, I've probably gone weird and wacky.
Say anything, man. Say anything.
Well, I will say this point about, one of the main questions is, like, when you measure these quantum objects and they become non-quantum, that doesn't make sense to any physicist. They don't get it. And this sort of spawns all of this thought about, I don't know if you've ever heard of like multiverses.
Yes, I have. A lot about multiverse, yeah.
So this sort of, people, physicists try and come up with like answers to like, what on earth is going on? And one answer might be every time a quantum thing is measured, it doesn't stop being both things at once because an extra universe is created. So every time you're measuring something, before it was both places at once, and it's still, you measure it and to us it looks like it's become classical again. It's lost its quantumness. It becomes just one place again.
Yes.
Maybe the answer to what on earth has happened there is the universe has created like a double. It's created a split off, and that other measure, the other outcome of that measurement exists in that other universe, if that makes sense.
So there's almost like an infinite number of universes being created constantly for every single scenario.
That's what multiverses are. Yeah. Every time that anything makes a decision, so it might, I talk a lot about single photons or quantum objects, like choosing whether to be reflected off a mirror or transmitted through a mirror. Like each of those decisions creates another universe. The choice about whether you go to the shops or not, or stay at home and watch TV, that's another type of choice. That's another universe that's created.
There's another universe in the multiverse, Danny, where United aren't shit, where they didn't lose 4-0 to Brentford.
And not many universes.
And they aren't bottom of the league.
Einstein said that quantum entanglement was spooky action at a distance.
There you go. That was the quote I was looking for.
And it's sort of the right way to describe it, as much as I hate it. Like, just describe, and we did spend a lot of time talking about all this spooky stuff. It is spooky. No one understands it. to be honest, I don't think I try not to talk about all the spooky stuff because it's interesting, yeah, for sure. But, when we try and build quantum computers, it's not useful, if that makes sense. So we try and avoid all the spooky stuff and focus on all the useful stuff.
Is it because it's a distraction or because you...
Yeah.
Yeah.
Well, because the team sit around, and if they've got a beer, all work stops and everyone sort of scratches their head and like, what on earth is happening?
The fuck? Yeah, but that's the best bit. It is like this spooky stuff. Are there any other spooky things?
Well, there's a ton of stuff, a ton of things in our lives that we don't understand.
Yes.
One of which being like consciousness. Like
I was about to say women. We'll come about that.
Well, I was going to say,
my daughter, God help me.
I'm on mic, so I can't talk about my wife.
Are we going to have to edit that one out?
Neil will probably say so.
Yeah, my brother would be like, Pete, you can't say that. You sound like Jeremy Clarkson.
Women may be one. Like consciousness, why any of us, like we're all like things, but we all have thoughts, we all have feelings, we all have, a soul, whatever. All of those things we don't understand.
Something came out about consciousness this week.
Yeah.
What was that?
I don't know.
Can you search Google News for consciousness? I saw something. What was it I saw?
Maybe this.
Here we go. Quantum physics could finally explain consciousness.
There we go.
There we go. I saw that this week. I never actually read it. I just saw the headline. All right, blah, blah, blah.
So I will say, so the headline says it all. Professor of philosophy weighs in.
Yeah.
Because, to be honest, at a certain point, I don't really think it's the job of a physicist because physicists are sort of weird people. They don't get out of the lab a lot. They shouldn't really be thinking about like consciousness, like what makes us people and things. But anyway, this is sort of to say that, and by the way, quantum physicists hate me for talking about this because no one really knows, but no one really understands how our brains work and that no one really understands how quantum physics works. Maybe some of this stuff is related to, well,
are our brains quantum?
Are our brains quantum? Yeah. And there are some cool things in, so for example, I think starlings, some birds, they can't explain how they're so good at navigating. So they sort of fly from one part of the world to another part. They're amazingly good at being able to do that. In a way, if we have our own sort of sensing devices, they're not as good as a bird, a sparrow at doing that. And so some people are sort of thinking, well, maybe that's because, and I think there might even be some proof to say inside of a bird's beak, I think it is a magnetic sensor that allows it to like locate magnetic north. But it's a quantum sensor. It's sort of something that relies on quantum mechanics to be better than any normal sensor could be. Yes. So there's all this stuff, like basically at the edge of what we think is possible, like quantum turns up. And this sort of, I guess, comes back to maybe the reason people think it's so powerful.
Can you scroll down a bit, Danny? The subatomic world. Early quantum physicists noticed that the double... Hey, we talked about
this
that.
article is given as our title.
Quantum physics and the consciousness are weird. It is also weird. Okay, what other weird stuff? Just let's give some weird juice to the listeners.
What else?
What blows your mind the most with this? When you think about it, you're like, that's just fucking insane.
To be honest, when I was a student going through this the first time, we spent a lot of time with quite a few beers trying to work out this whole measurement thing. Like, and we just came up with some crazy ideas. We're sort of like, well, hang on a minute. Maybe, and this is going to sound a bit weird, but maybe there's like another type of creature out there that's like another level of consciousness so we think we're making measurements. We think we're watching these quantum systems and like, okay, quantum changes because we're observing them. Maybe there's like another type of measurement. Maybe there's another type of being. We're just existing in what another being would come and look at and be like, well, that's weird. That doesn't, do you know what I mean? Maybe there's lots of different.
But the simulation, maybe.
Yeah. And maybe, I don't want to sound too weird, but maybe we are living in a simulation. It's just it sort of blows your mind to imagine that we're all living in this strange quantum mechanical world and none of us have a clue what it is, even, let alone how it works.
So the simulation stuff, to me, I was like, yes, just sounds like bollocks until, who was it explained it? And the way, maybe it was Elon Musk who explained it. He said, but if you look at how far computers have advanced in like 30 years, maybe 30 years ago, we first played SimCity and we could just build a road and now the crazy shit you can do with them. But that's a short amount of the human time span. We've been here for thousands and thousands of years, but the planet's millions of years. Trying to imagine the advancement in 10,000 years in computing, you can see a scenario where you could have the ability, maybe with an Orca machine to create a simulation of the Earth. And if that's possible, then the most likely outcome is that we are in a simulation.
Absolutely, yeah. It blows my mind. We work with one bank, and the guy we work with in the bank sort of basically advises all of his incoming graduates. He says, if you don't learn how to program a quantum computer now, well, you should start, because in the course of your career, it will change the face of computing. So, make sure you learn how to program a quantum computer, because at some point we're going to find that it's useful, and at some point it's going to completely dominate everything you're doing.